because I've talked a little bit about several different times. The paper from 2024 about the salience network with 6-week-old human beings, human infants, and the salience network. This was done at UCLA, Sang et al. And Lucinda Uden is on this paper, Uddin. Lucinda Uden kind of really captured the role of the insula. And about 2008, 2010, and so forth was a really hot year for the insula, or years. Still is. It still is. But on 6 week, this study on 6 weeks old, they used fMRI during non-activity, so it's almost like a sleep state. On humans, though, they found that children that had a high likelihood of having autism. So they had autism as their siblings already had autism. So they would hook fMRI up to these human babies and just check their connections essentially. And the high likelihood found that the salience network had a strong connection to this area right here, the sensory motor area, which is right here. A lot of our not adaptive responses, but a lot of our automatic responses will live here versus here. We like to send a lot more reflexive things, habitual things up to here. And then it can just feed down into the dorsal striatum and then kind of sort the basal ganglia for movements and actions. So they found, 6 weeks old, a stronger connection to the sensory motor area. And if you think about autism and kind of the rigid thinkingness and lack of cognitive flexibility, right here, versus the typical likelihood, the other children, 6 weeks old, they had a stronger connection with areas here. It's a big finding, but nobody does anything with it. It's just kind of lost in the academic literature. Nobody does anything with this stuff. And what's fascinating here is, it's UCLA. It's like an ivory tower. They followed these kids up that, because they were only 6 weeks old, they followed them up to like years 2 and 3. And they could confirm, like, the ones that had a stronger connection to here, definitely indeed, autistic phenotype. Nobody does anything with this stuff, though.